Hello there, welcome to this video where I will be presenting the derivation of the quadratic formula. It is a well-known formula, and those who are doing mathematics usually have the curiosity or the desire to know where things come from and how they come about. So it is my intention in this video to really take you through the process of the way in which this formula was formed and really what it means in terms of its application. Okay, so because it's a quadratic formula, obviously it means that it comes from a quadratic function. Okay, and what is the standard format of a quadratic function? I'm going to label it as g of x is equal to ax squared plus bx plus c. Okay, and assuming that you've taught the students the effects of a, b, and c in the function itself, and also that you've taught the algebraic process known as the completion of a square, and that is the crucial method in which you arrive at this particular formula. Okay, so from the standard format, what you want to do now is to complete the square by first factoring out the a, and then in the brackets the resulting expression is what you use to complete the square, because that is really the starting point of that process to ensure that the leading term has a coefficient of 1, and then you can proceed. Okay, so let's go for it. This will be equal to a x squared plus bx over a plus c over a. Okay, now in the next step, I will then do step 2 of the process, where I add and subtract half of the square of the coefficient of the middle term, yes, plus bx over a. So the coefficient is b over a, half of that, and we square that. It means we'll have b over 2a, we square that, we minus b over 2a, we square that. Okay, come back to this guy, plus ca, close the brackets. Our first three guys here will give us the square of a binomial. So we go a x plus b over 2a all square. Okay, then what that becomes is minus b squared over 4a squared plus c over a. Okay, now we can clean up by multiplying the a into the brackets. A x plus b over 2a squared minus b squared over 4a plus c is the resulting expression after distribution of the a. Now, we're looking for the values of x, or the solutions for x, or in some literature they call it the roots of this equation. And really this represents the x-intercepts, and at the x-intercepts the y-coordinate is 0, and this entire notation here represents your functional values, or your y-coordinates for corresponding x-coordinates, which gives you a point. Yes, so now we're going to equate this expression to 0 and solve for x and see if we arrive at that particular expression, okay, or formula. Right, so here we are. Now we're going to transpose these two guys here to the right hand side and work with the LCD. We end up with ax plus b over 2a all square is equal to b squared minus 4ac over 4a. All right, and division both sides by a, we end up with x plus b over 2a squared is equal to b squared minus 4ac over 4a squared. Okay, what do we want? We want to solve for x now. Power of 2 means there are two possible solutions for x, and therefore the plus and minus will come in to now have x plus b over 2a equal to plus or minus square root of the entire fraction, b squared minus 4ac over 4a squared. what do we notice? The denominator of that fraction is actually a perfect square, or the product of perfect squares, much more precisely stated. So square root of 4 will give us the 2, and square root of a squared will give us a. So we end up with x plus b over 2a equal to plus or minus, well, that will remain as it is, b squared minus 4ac all over 2a. And as you can see, when you transpose the b over 2a to the left-hand side, you'll end up with the same denominator. You can group your numerators, and you definitely end up with your quadratic formula. X is equal to negative b plus or minus square root of b squared minus 4ac over 2a. Okay, now we can jump into the meaning of this formula and how we can apply it. So I will now split the formula and show you that there exists a relationship from the axis of symmetry to your roots. Okay, so if we go x equal to minus b over 2a, we take the plus b squared minus 4ac over 2a, right? Or this one, x equal to minus b over 2a minus square root of b squared minus 4ac over 2a. So how many roots do we have? 2, right? And obviously you go deeper into this when you study nature of roots. But what is common? This. X is equal to minus b over 2a. Recall that if that is your parabola, this imaginary line that cuts the graph into 2, that is your x equal to minus b over 2a. We call it the axis of symmetry. Okay, and if we are now in the Cartesian plane, there is our x, and suppose that imaginary line is the y-axis. It's not always the y-axis, but for the purpose of this discussion in this video, that is what I'm going to take. All right, so this tells you there's a root to the right, okay, and this tells you there's a root to the left relative to the axis of symmetry. So from here I get to a root, which is the x-intercept, and from the axis of symmetry I get to my root here, one to the left and one to the right. Okay, and those are your application points of what this formula means and how to use the graph to interpret how it works. Okay, so this takes care of this presentation. I believe that it added value to your understanding of this well-known formula, and you will use it successfully in the future. Thank you for watching.